Did you know that it exploded? Betelgeuse releases more energy per second than our sun produces in a single instant in its entirety. That's an incredible event. Will we see it from Earth in a few weeks? Located about 642 light-years away, the star has caught the attention of astronomers due to its enormous size, irregular dimming, and potential for a supernova explosion. Recently, celebrities such as Elon Musk and Michio Kaku have weighed in on the possibility that the star could impact Earth, raising concerns that a supernova event could occur within the next 2 weeks. This speculation has sparked widespread interest and concern about the potential impact on science, technology, and humanity's understanding of cosmic phenomena. Betelgeuse is nearing the end of its stellar life cycle, and these types of stars experience dramatic changes as they become unstable and change in size as their nuclear fuel runs out. This instability has led some astronomers to speculate that one of the most powerful events in the universe, a supernova, is imminent. If Betelgeuse were to become a supernova, the explosion would temporarily darken the entire galaxy, cast a shadow on Earth, alter the natural light cycle, and potentially affect both human and environmental activities. The brightness is so intense that it can be seen during the day, disrupting sleep patterns, affecting nocturnal wildlife, and influencing plant behavior. Additionally, cosmic radiation and high-energy particles from the explosion can interact with Earth's atmosphere. Even if the planet's atmosphere protects life from harmful radiation, the event can still increase ionization in the upper atmosphere, potentially disrupting satellite communications, GPS systems, and even aircraft navigation. Atmospheric phenomena such as the northern lights also occur, visible from far away in polar regions, and serve as a reminder of the great power of the universe. Musk and Kaku's comments have deepened the debate surrounding the Betelgeuse event. Musk, known for his investments in space exploration and SpaceX, emphasizes the importance of interplanetary colonization as a means for humanity's survival in the face of global threats. A supernova explosion could accelerate efforts to establish human colonies on Mars and beyond. On the other hand, theoretical physicist Kaku noted that this event was a rare opportunity to observe a supernova in real time, which could provide greater insight into the changing interstellar system and cosmic events. The potential explosion has sparked discussions about precautions to mitigate its impact. While humanity cannot prevent a supernova, it is important to prepare for its consequences, such as protecting satellite infrastructure and power grids from space disturbances. Radiation from such an event could pose health risks that would require enhanced protection, especially for astronauts aboard the International Space Station or those on future missions to the Moon or Mars. The scientific community also speculates about the potential climate consequences. While a direct burst of supernova radiation would not have a significant impact on Earth's climate, secondary effects, such as increased spacecraft activity, could affect cloud formation, potentially influencing local weather patterns. Changes in UV radiation affect the ozone layer, and while these changes may not be harmful, they can still affect agriculture and atmospheric chemistry. Beyond the world of science, these explosions will have profound consequences for world culture. Throughout history, people have found inspiration and connections with stars. The tragic death of a famous star like Betelgeuse could rekindle interest in astronomy and science, reminding us of the transience of life and making us think about our place in the universe and the legacy we wish to share. Depending on operating conditions, technological advances could be accelerated. Historically, major celestial events have influenced culture, and the Betelgeuse supernova could inspire new artistic and cultural expressions. Such explosions can be seen in literature, music, and art that express themes such as change, birth, and the passage of time. International events can also increase public interest in space exploration, inspire younger generations to pursue careers in STEM fields, and spur global support for space missions. The explosion could be an event for the global space program similar to the impact of the Apollo moon landings. The implications for space policy and international cooperation would be profound, highlighting the need for planetary defense and rapid preparation for space-related challenges and opportunities. While space agencies have traditionally operated independently or in limited partnerships, events such as the Betelgeuse supernova could encourage a more integrated approach to space exploration. The sighting of a nearby supernova could spur nations to work more closely together on major space initiatives, recognizing that the benefits of exploring and understanding the universe extend beyond national borders. Efforts to monitor, study, and respond to the Betelgeuse event could lay the groundwork for coordinated asteroid defense strategies, joint missions to outer planets, or more collaborative projects such as building bases on the Moon and Mars. Given Musk's emphasis on colonizing Mars, the supernova could accelerate efforts to build settlements beyond the planet. While the event itself may not pose a direct existential threat to Earth, it serves as a reminder of the instability of the universe and reinforces the need to create backups for human civilization. Seeing Betelgeuse's explosion could also have implications for the search for extraterrestrial life. One of the greatest challenges in astrobiology is understanding how planetary events such as supernovas affect the existence of planets. The energy release from a nearby supernova could change the criteria used to find habitable exoplanets by considering the effects of near-planet explosions on planetary environments. The Earth's atmosphere protects life from atmospheric radiation, but it also has significant secondary effects on atmospheric chemistry, altering greenhouse gas composition and potentially affecting temperature. Over time, the agricultural sector may be indirectly affected by changes in weather patterns or changes in solar radiation levels. While supernova energy releases do not dramatically alter climate, even small fluctuations can affect plant growth cycles, crop yields, and seasonal patterns. Philosophically, a nearby supernova forces us to reconsider humanity's place in the universe and our vulnerability to cosmic forces. The demise of a giant star like Betelgeuse highlights the transience of even the most monumental cosmic structures, reminding us that we are governed by cycles of birth, life, death, and change. Space emergency management strategies could include protocols similar to those used for space weather events such as solar storms. Preparing for a Betelgeuse explosion could include hardening infrastructure, including power grids and communication systems, to withstand potential electromagnetic disturbances. The visibility of the event could also influence public policy on space exploration and resource allocation. Supernova observations are likely to increase funding for space research, leading governments to prioritize astronomical observatories and space missions. The legal implications of this event could prompt a reevaluation of space law and international treaties. For example, the 1967 Outer Space Treaty laid out the basic principles for space exploration, but the explosion could accelerate efforts to colonize space, sparking interest in legislative revisions to address scenarios such as asteroid mining, control of the Moon and Mars, and property rights in space. The potential impacts on Earth's atmosphere and climate could inspire research into how cosmic events affect the natural world. High-energy particles from supernovas interacting with the atmosphere could subtly affect weather patterns by affecting greenhouse gas distribution or changing the microphysics of clouds,